So let's start with the pre-industrial revolution era, a time before 1800s. Imagine a world where everything was made by hand, craftsmen work in small workshops, passing their skill down from generation to generation. There was no factories as we know them today. A single craftsman will create an entire, product from start to finish, whether it was a chair, a shoe, or a tool. This was the time when skill and craftsmanship were highly valued, but production was slow and costs were expensive. Then came the Industrial Revolution era, which completely transformed how we make things. This was like awakening a sleeping giant. Suddenly, we have steam engines powering large factories, machines replacing hand tools, workers specializing in specific tasks rather than making entire products. So think about how revolutionary it was. Instead of one person making an entire shoe, now you had different people specializing in cutting, leather, stitching, and finishing. This made production faster and goods more affordable for everyone. The scientific management phase followed, bringing a completely new way of thinking about work. Frederick Dealers and the Gilberts started studying work scientifically, measuring time, analyzing movements, and finding one best way to do each task. Imagine someone for the first time saying, let's not just rely on tradition, let's use science to figure out the most efficient way to work. This was when industrial engineering truly became a science. During World War II, we entered the operations research and quantitative phase. This was when mathematics and statistics became powerful tool in decision making. Military planners needed to optimize everything from supply routes to resource allocation. These methods later transformed civilian industries. Think of it as moving from gut feelings to data driven decisions. We started using mathematical models to solve complex problems like inventory management and production scheduling. Finally, we arrive at our current automation and computer integrated manufacturing phase. This is where computers and robots become central to manufacturing. Imagine modern factories where machines communicate with each other, make decisions automatically, and adjust their operations in real time. We are now talking about small factories where artificial intelligence and data analytics optimize every aspect of production. Each of these phases build upon the previous ones, creating the rich tapestry of modern industrial engineering. We are not just looking at technology change here, we are seeing the evolution of how humans organize work and create value, from hand tools to start factories, from craftsmen to robots. The journey continues to evolve. Okay, before 1800, the world of manufacturing was entirely different from what we see now. There were no factories as we know them today. Instead, skilled craftsmen worked from their homes and small workshops, creating products by hand. Agriculture was the dominant economic activity, with farmers producing both food and raw materials like cotton and wool. But then came a pivotal moment in history, the development of the steam engine by James Watt in 1774. This wasn't just another invention, it was a revolutionary breakthrough that would change the course of human history. Imagine the amazement of people seeing for the first time a machine that could provide consistent, powerful energy without relying on human or animal power, wind, or water. The steam engine became the heartbeat of coming industrial revolution. 2 years later, in 1776, a Scottish philosopher named Adam Smith published his groundbreaking book, The Wealth of Nations. In it, he introduced concepts that we take for granted today but were revolutionary at that time. Smith proposed that work should be divided into specialized tasks. Imagine a single craftsman no longer making an entire product, instead becoming the expert at one specific part of the process. This division of labor concept would later become the fundamental to the modern manufacturing. Then in 1798, Ellie Whitney made another breakthrough that would transform manufacturing forever: the concept of interchangeable parts. Before Whitney, if part of your musket broke, you needed a skilled craftsman to make a new part specifically for your weapons. Whitney innovation meant the part could be mass produced to standardized specifications and would fit in any musket for the same order. Think of it like modern day Lego pieces. They all fit together perfectly because they are made to exact specifications. These three developments, what steam engine providing reliable power, Smith's division of lever organizing work more efficiently, and Whitney's interchangeable parts enabling standardized production laid the crucial groundwork for the industrial revolution that will follow. They represent the bridge between the old world of craftsmen and the new world of industrial manufacturing that was about to emerge. Just imagine these changes that happened within a span of 24 years will go on to transform not just manufacturing but the human society itself. The principles established during this period still influence how we organize work and the production today. Okay, the 1800 marked an extraordinary transformation in human history. The emergence of the factory system. This wasn't just a change in where people work, it represented a complete revolution in how work was organized and managed. Imagine the transition from the small workshops where craftsmen made entire products by hand to large factories where hundreds of workers operated machines and followed standardized processes. This new way of working created challenges and that had never been seen before. As factories grew larger and more complex, they required an entirely new approach to management. The old ways of organizing work, where a master craftsman supervised a few apprentices, simply wouldn't work in these massive new facilities. Think about the challenges of coordinating hundreds of workers, maintaining complex machinery, managing raw materials, and ensuring consistent product quality, all while trying to meet growing market demands. This was something entirely new in human history. One of the significant development during this period was the creation of sophisticated manufacturing processes. Unlike the simple tools and the methods of pre-industrial era, factories needed carefully planned production lines, standardized procedures, and quality control systems. Manufacturing wasn't just about making things anymore. It became the science of its own, requiring deep understanding of materials, machines, and methods. The new industrial war created an urgent need for the technically skilled professionals. Factory owners quickly realized that successful operations required people who understood both the technical aspects of production and the principles of management. This was the birth of what we know as industrial engineering, professionals who could bridge the gap between technical knowledge and management skills. During this transformative period, two names emerged that will forever change how we think about industrial management: Frederick Taylor and the Gilberts, Fred and Lillian. Their work laid the foundation for the scientific management, a revolutionary approach that would transform industry forever. Taylor began the study of work processes in details, breaking them down into their smallest components to find the most efficient methods. The Gilberts focused on the motion study and the large human aspects of work, considering not just efficiency but also about the worker well-being. This era wasn't just about the technological change, it was about creating entirely new ways of thinking about work, efficiency, and management. The principles developed during this time still influence how we organize and manage production today. Think about modern factories with their emphasis on efficiency, standardization, and skill management. All of these concepts trace their roots back to the Industrial Revolution. The period from 1910 to 1933 marks what we call scientific management era. This wasn't just another time in history, it was a complete transformation in how we approach work organization and industrial efficiency. Think of it as the period where industrial management truly became a science. It began with Frederick Winslow Taylor in 1910. We call him the father of industrial engineering. And for the good reason, Taylor introduced something revolutionary, the idea that every job could be study scientifically to find the one best way to do it. Imagine someone for the first time saying, let's not just rely on the tradition or gut feeling, let's use scientific methods to study and improve work. He will spend hours observing workers, breaking down their tasks into the smaller components and finding ways to make each movement more efficient. Then came the Frank and Lillian Gebhardt in 1911, bringing a fascinating new perspective to motion study. While Taylor focused on time, the Gebrarts focused on movement. They would film workers and analyze their motion frame by frame. Imagine watching a video in slow motion to identify every unnecessary movement. Lillian Gilbert also added a crucial human element, considering the psychological and physiological aspects of work. Henry Gann made his mark in 1930 with something we still use today, the Gantt chart. Think of it as the first project management tool that visually showed when tasks should start and finish. It was so revolutionary that is still a fundamental tool in project management software today. In 1917, Harris Decker, a different challenge, inventory control, he developed mathematical models to determine optimal inventory levels, balancing the cost of holding stock against risks of running out. This was the beginning of scientific inventory management. Walter A. Shewhart brought statistics into quality control in 1924. His statistical control charts revolutionized how we think about quality. Instead of just inspecting final products, he showed how to monitor the production processes itself to prevent defects from occurring. In 1927 to 1933, Eldon Mayo conducted his famous Hawthorne studies, revealing something surprising. Worker motivation is not just about money or physical conditions. He showed that the social relationships and feeling value at work significantly impact productivity. Finally, in 1933, Ralph Barnes developed comprehensive work study methods, combining the best of all previous approaches into systematic methodology for analyzing and improving work methods. Each of these contributors built upon the work of others, creating a comprehensive science of industrial management that we still use today. Think about modern efficiency tools, quality control methods, or project management software. They all trace through their roots back to these pioneers. This era marked a dramatic shift in how we approach industrial decision making. For the first time, we began applying rigorous mathematical and analytical methods to solve complex operational problems. Imagine moving from making decisions based primarily on experience and intuition to using sophisticated mathematical models and statistical analysis. World War II served as the catalyst for this transformation. During the war, military planners faced unprecedented challenges in managing resources, how to optimize the deployment of military assets, manage supply chains across continents, and coordinate complex operations. This led to the development of operations research, a systematic approach to decision making that used mathematics and statistics to optimize resource allocation. Think about the planning a massive military operations. You need to consider countless variables like personnel, equipment, timing, and logistics, all while working with limited resources. A major technological breakthrough came in 1956 with the development of fast numerical control machine. This was revolutionary. Imagine a machine tool that could be programmed to perform complex operations automatically with precision that surpassed human capabilities. Instead of relying on skilled machinists to manually control every operation, these machines could follow pre-programmed instructions, ensuring consistency and accuracy in manufacturing. Then in 1961, we witnessed another milestone, the introduction of the first industrial robot. This wasn't just another machine, it was a programmable device that could perform various tasks with flexibility and precision. Picture a mechanical arm that could weld, paint, assemble parts tirelessly day after day with consistent quality. This marked the beginning of the true automation in manufacturing. In 1965, these developments culminated in the concept of flexible automation. This represented a significant leap forward from rigid simple purpose automation. Flexible automation systems could be quickly reprogrammed to handle different products and processes. Think of it having a versatile workforce of machines that could switch tasks as needed, allowing manufacturers to respond more quickly to changing market demands. These developments collectively transform industrial engineering from a discipline focused primarily on human work methods to one that embraces sophisticated technological solutions, mathematical optimization. The principles and methods developed during this era still form the backbone of modern industrial operations, from computer control manufacturing to automated warehouses. The modern phase brought us into the era of smart and automated systems, fundamentally changing how we approach manufacturing and industrial processes. Imagine walking into a modern factory instead of rows of workers performing repetitive tasks. You'd find sophisticated machines communicating with each other, making real time decisions, and adjusting their operations automatically. These smart systems can predict maintenance needs, optimize production and schedules, and even learn from their own performance data. One of the most significant developments during this phase was the introduction of lean manufacturing and just in time concepts. Pioneered by Toyota, think of it as a complete reimagining of how we manage production. Instead of maintaining large inventories just in case, companies now aim to have materials arrive just in time when they are needed. Lean manufacturing is like conducting an orchestra. Every element must work in perfect harmony, eliminating waste and maximizing efficiency. For example, a car manufacturer using GIT might receive seats exactly when they are needed for assembly rather than storing thousands in a warehouse. Computer-aided manufacturing, CAM, and robotics have taken automation to new heights. Modern robots are not just programmable machines, they are sophisticated systems that can feel, see, and adapt to their environment. Picture a robotic arm that can detect when a part is slightly misaligned and adjust its movement accordingly, or a 3D printer that can create complex components with precision that would be impossible by hand. These systems have not only improved accuracy and consistency but also enable the production of items that would be impossible to manufacture using traditional methods. Perhaps most exciting is the integration of artificial intelligence and data science into industrial engineering. This is not just about collecting data, it's about using advanced algorithms to drive meaningful insights and make predictive decisions. Modern factories are equipped with sensors that constantly generate data about every aspect of production. All AI systems analyze this data in real time to optimize operations, predict equipment failures before they happen, and even suggest improvements to production processes. Imagine having a system that can predict when machine will need maintenance before it breaks down or automatically adjust production parameters to maintain optimal quality. These advancements represent not just technological progress but a fundamental shift in how we think about manufacturing and industrial processes. We are moving from reactive to predictive operations, from fixed to flexible production, and from human dependent to AI enhanced decision making systems.